In this video, we will learn how to use logarithms to help us solve exponential functions and equations that don't follow the basic properties of exponentials. So if we take a look at this equation, we have 1/3 times 2 raised to the x plus 4 equals 5. Our goal in this is to isolate the exponential term so that we can then use a logarithm to help us solve it. So the very first thing that I would want to do with this is to subtract the 4 off of both sides. In doing so, we get the equation 1/3 multiplied by 2 raised to the x is equal to 1. Now our next step, we want to further isolate this exponential term, the 2 raised to the x. So in order to do that, we need to get rid of this 1/3. Right now, the 1/3 is essentially dividing off of 3, so we want to do the opposite of that and multiply by 3. So if I multiply both sides by 3, the 3 and the 1/3 on the left side will cancel each other out and leave us with 2 raised to the x equals 1 times 3 is 3. Now at this point, I don't know what power of 2 gives me 3. So I need to use the inverse properties of logs and exponentials to rewrite this as a logarithm. So I'm going to take this base of 2, shift it over to the right side, but use it as a logarithm base. So this will become x on the left side and a logarithm with a base 2 of 3. The base of 2 stays the base of 2, but it becomes the logarithm base on the opposite side of the equation. If we wanted an exact value, we could use exactly what we have on our screen right now, which is log base 2 of 3. But in order to evaluate this for an approximation, if we needed that, we would have to use our change of base formula, which is the log of what was inside divided by the log of the base. So using that on our logarithm here, I can say that this is the log of 3 divided by the log of 2. And if I type that into my calculator, I can then see that this is approximately 1.585. So we isolated the log or the exponential first. We then changed it over to a logarithm using our inverse properties, and then used the change of base formula to help us to evaluate it and approximate the answer. And that's how we go step by step to solve an exponential function using logarithms.